So now that we've set the stage for what Euler's method means in terms of tools that we've already been familiar with either in this class or others, we're going to go ahead and talk about how to find numerical approximations to ODEs. And so the general idea is that we're going to start at some point, x0, y0. We know that we can compute f of x0, y0. To find the slope of the tangent line to some unknown y of x. And then we can follow that line to recreate y of x. That's kind of how we approximated the differential equation solution curves graphically. You could have used the exact same description, but we're going to be doing it algebraically now. And we're going to do that by implementing Euler's method. And so that's going to just involve a few simple steps. So we're going to think about this for a differential equation, dy dx equal to f of xy, with an initial condition y of x0 equals y0. So if our goal is to solve that thing, we're just going to start at our x0, y0. We're going to compute f of x0, y0. We're going to update x1 is equal to x0 plus h, and y1 is equal to y0 plus h times f of x0. Oops. Y0. And then we're going to repeat until we reach the x value where we want to stop. So we're just going to go back to the, that's a really lopsided arrow. We're just going to go back to the beginning. And then we're going to have sort of that in the next iteration, you would have that you start from x1, y1, compute f of x1, y1. x2 is x1 plus h, y2 is y1 plus h times f of x1, y1, and so on. I'm going to erase all those things because they're kind of a mess. And so some important things that happen in these steps is that after you know the differential equation to solve, you need to pick h, the step size, and then decide when to stop. So it'll be like, what is y of 2? Then you stop at x equals 2. So that's the general approach to Euler's method. And we're going to do this with a approximation example. So let's just go ahead and start this example, and hopefully it'll be a little bit clearer. So the differential equation that we're going to do is going to be y prime is equal to 0.1 square root of y plus 0.4 x squared. And we're going to have the initial condition y of 2 is equal to 4. And whenever you have a problem like this in class, you'll just be sort of told the step size to use and where to stop it. So for this one, we're going to say that we want y of 2.2. Okay, so all of that information is something that you would be given for a problem to solve. So for the time being, don't worry about what h means and how to get a good one. Somebody will tell you what to do. And what I'm going to do real quick, since this is kind of our first time doing this, is I'm just going to make sure that we understand the notation here. The thing that we've been calling f of xy this whole time is that 0.1 square root y plus 0.4 x squared. Our x0, y0 is that initial condition. The x value is the input, and the y value is the output. And then we were given our h is equal to 0.1, and we want x equal to 2.2. And then that'll tell us what the y value is there. So for me, it's easiest to just do these things kind of in a list. So I have x0 equals 2, y0 equals 4. So I could find f of x0, y0 is equal to 0.1 square root 4 plus 0.4, 0.4 times 2 squared. And I did this beforehand so that you wouldn't sit here watching me do arithmetic. So I'm going to say that my next step was going to be x1 is equal to 2 plus 0.1, and y1 is equal to 4 plus 0.1 times that whole thing right there, 0.1 square root 4 plus 0.4 times 2 squared. And that is 4.18. And before I go on here, I just want to make sure that it's kind of like really clear to everyone. When I computed these update steps right here, that's on the previous stage, this thing right here. So kind of the start of the problem is bookkeeping, just what are the points I start at, what is my function, and then the important Euler's method part is that step 3. And so I'm just going to write right below it that I said x1 is equal to x0 plus h, y1 is equal to y0 plus h times f of x0, y0. That's what we were doing in that step. In case the notation and all the numbers is kind of intimidating, just we'll have those things right there. And so now I have new values. X1 is 2.1, Y1 is 4.18, but I have to keep going until I have the X value I want. So I could say, okay, X2 is, X1 plus H. So that's just going to be 2.1 plus 0.1. So that's 2.2. So great. This is going to be the last thing I have to do. So my Y2 is y1 plus h times f of x1, y1. And so that's going to be 4.18 plus 0.1 times 0.1 square root 4.18 plus 0.4 times 2.1 squared. Again, this is a lot of arithmetic. I did it on a calculator before this. It's 4.3768. And so this is a whole mess of a lot of numbers, but I've done the thing that I was supposed to do. I was supposed to compute y of 2.2. I think it's that thing. I know that this was a lot. We're going to stop right here. And then in the next video, we're going to talk about what happened and make sure that all the notation's clear.